Okay, next is reabsorption. Just now we have seen the ultrafiltration process due to high pressure. Ultrafiltration is due to high pressure from the efferent and efferent. Okay, now we will see the reabsorption. So reabsorption is from the renal tubule. So the reabsorption happen from the renal tubule into the blood capillaries. Okay, as you see here just now. Okay, so from the renal tubule, the green one is called the renal tubule. Okay, the red one is the capillary. So from the renal tubule back to the capillary. So because just now when we say glow ultrafiltration, everything is entering. Okay, everything inside the blood already enter the Bowman capsule. So now they remain inside the tube. Okay, so how to remove those extra, because everything is being filtered in. Okay, it's not everything that you must remove. Okay, some other things, most of the things you are still needed. We just want to remove those excess one. Okay, so at every tubule, okay, PCT, remember, proximal convoluted tubule, Henle, distal convoluted tubule, and then conducting tubule. There are substances that being remove, or sorry, reabsorb. Reabsorb means entering the blood capillary. This is to enter back to your body. When we call reabsorption into the blood capillary means absorbed by your body. So 60% of the water will enter into the body. The sodium through active transport. Active T means active transport. Water osmosis. So sodium also into the blood capillary. So 100%, sugar and amino acid, it go back to the blood, into the body. So that's why you do not have your glucose in your urine. Okay, so because all is going back into the blood capillary. So if you have glucose inside your urine, means not 100%, then it will cause glycosuria. Okay, and then large amount of all these ions, okay, potassium, chlorine, hydrogen carbonate, calcium, magnesium, all these will be reabsorbed back into the body. Okay, into the blood capillary. At the loop of Henle, we will again, okay, water, sodium, and chlorine is being removed into the blood capillary, reabsorb. Okay, so then if you see after the PCT, when they enter loop of Henle, now the filtrate are low in salt. Okay, because sodium and then sodium two place, okay, is being take out. Okay, that means there's less salt inside the tubule now. Okay, at the DCT, you have again water, sodium, and chloride being removed some more. Okay, so this one is to remove most of the water and sodium into body. Okay, we do not want to remove too much of this. Okay, unless it have too much of water in the body. Okay, then we will do remove less water into the body. Okay, we will remain inside the tubule. Okay, you see, this second process is to remove from the tube, means enter, absorb again by the body. Okay, means it's not removed. The whatever that is being out from here is inside the body. Okay, oh, and then later we will see the last process, secretion, is opposite of this. Okay, so at the collecting duct, you will have very little salt left, and then 99% of water is absorbed. This is normal. When you have normal amount of water, drink, okay, consume. Okay, now last process is secretion. Okay, secretion, the function is to secrete waste and excess substances that were not initially filtered. Means at first when we say Bowman capsule, Bowman capsule, you should have filter everything inside. Then from the Bowman capsule, they will enter the tubule, the distal, the proximal, the loop of Henle, to select things that must remain inside the tubule. But let's say there are something that is inside the blood that is not being filtered inside the Bowman capsule. Okay, now we need the secretion process. Okay, secretion process, the direction is opposite. Okay, so we will see there's only 20% of the plasma enter the Bowman capsule. BC means Bowman's capsule. Initially means at the beginning. So then there will be some waste product remain in the blood. See? So after the blood leave the Bowman capsule, it still have some waste product. So we must remove the waste product from the blood. So how to do that? Okay, we will need this secretion process. Secretion will involve ADH. Okay, so yeah, so secretion will involve ADH, and along the tubule, especially at the DCT, distal, okay, they will have passive and active transport to remove the waste product. The secretin substances, okay, these are the one from the blood, okay, is not into the bone capsule. So when the blood capillaries was move or flow near the DCT, these substances will enter the DCT, okay, enter the tube to be removed as urine. So these are the one, okay. Then also this ADH in the blood, okay, will affect this DCT. The membrane of it become more permeable, okay, become more permeable to all this, so that it can be removed. Okay, next we will see what happen when the kidney is not functioning. Okay, then we will have to help. Okay, these are the machine, the hemodialysis machine, to help to filter the bloods if the kidney are not functioning. So what I want to see is, yeah, this is the one. Okay, the blood is from the person, the patient enter the machine will clean the bloods, and then it remove, and then it send it to the patient. Okay, the patient have to do this through 2 times a week, okay, to the center, at the center. Okay, later I will share you how the hemodialysis is being carried out. So you see the blood go into the machine, and then the blood come out. Okay, this is the simplified one. Okay, this is also another diagram. Okay, so what is inside the machine? So inside the machine you have, this one you must know. Inside the machine you will have this dilate, okay, dialysis solution. Okay, can see dialysis solution. This dialysis solution is isotonic to the body cell. Okay, isotonic to the body cell, meaning to say whatever the blood that from the patient, if the blood is higher concentration, how to say, have higher concentration of glucose, so the glucose will enter here. Okay, if you have more waste product, the waste product will be here. This is isotonic. Isotonic means it should be, at the end of the day, the one that enter the bloods, the one that enter back to the patient should be the same concentration as the dialysis solution here. Means the isotonic of the blood concentration. Okay, so now you see number 2, the net diffusion autopsy is from the blood to the dialysis fluid. Require ions added. Okay, so this one is to make the dialysis solution. Okay, and last one, the filter blood re-enter the blood vessel. Okay, so this is the SPM question, so you have to know. Okay, so this is quite fast. Okay, as you see the one in red, okay, you see the blood in, it will carry a lot of things, but when it come out, okay, this come out, it will be the same as the blue, see, as the dilate, meaning this part is in the machine, is in the body of the patient. So the body of the patient, when the blood enter, it carry a lot of yellow blue. The red is the red blood cell. Red blood cell remain, okay, it will not go out. But the blood plasma here, the yellow one, it will be removed, because here you still have your water. The water concentration, osmotic pressure is the same here, so that your after the process, the patient will not lose too much of water. Let's say I do not put water in this machine, I mean this is not isotonic to the blood, meaning the water from the patient will also be coming out. Okay, you see this machine, the process is osmosis or diffusion. Okay, osmosis and diffusion. So if we do not put the same isotonic solution to the blood, okay, at the end of the day, after the blood enter the machine, it come out, it only red blood cell, cannot be lah. Okay, so what we have can see here, this machine must dialysis solution. The solution is not water only, it contains certain nutrients, okay, which are isotonic to the blood. So at the end of the day, the person will still have nutrient in the blood, still have water, still have some salt in the blood. Okay, not all things are being removed. Okay, only those waste material is being removed. Okay, so that is the idea of the dialysis solution. Okay, you got it? Okay, we need the dialysis solution so that is isotonic to the blood. Okay, same concentration, same osmotic pressure with the blood, so that the not everything inside the blood is being removed. Okay, got it? Okay, so last one is to practice the healthy lifestyle for human. 3.5 is the lifestyle. So we have certain substances that affecting the nervous system. For example, the drugs and the alcohol. So drugs we can divide into three groups. The stimulant, the depressant, and hallucinogen. This one you get from your textbook, please. Okay, just read up. Okay, there are a lot. Okay, if you go Google, there are a lot. But the one that is in your textbook is more important. Okay, you just read up that one, understand that one. Okay, so we will stop here. Okay, then we will go to the last one, which is 3.6. 3.6 will be plant hormone, which is the last part of the chapter 3. Okay, so I hope you can understand, and then I will see you again next time. Thank you.